Good morning, everyone. Today we will start practical session in digital electronics lab. We are having total 3 groups: Group A, Group B, and Group C. Group A is having assignments on combinational circuits. Group B having assignments on sequential circuits, and Group C is about a case study and the study assignments. Now, before starting actual assignments, we'll see the basic example and how we are implementing this basic example by using trainer kit. Now, how to handle the trainer kit. So, this is a trainer kit we are using to perform the assignments, all the assignments of your daily lab. So basically these trainer kits having a different sections. So first section is related to your input part. So total 8 ports are given for the input purpose. These are the switch we are considering for the input purpose. So here it is clearly mentioned that if it is upper side, then it will be blink. If it is switch is downside, then it will be considered as a 0. Now another section is your socket sections. Now we are having a different socket sections. So here total actually 5 sockets are there. This green socket, it is indicates as zip socket. It is a zip socket. So we are having a 40 pin zip socket, here 20 pin zip socket, and other also are having a 20 pin zip socket. So here you can observe, here there are number of pins are mentioned. So if it is 40 pin sockets, then total 40 pins are there. Now if it is 20 pin socket, then 20 from P1 to P20 pins are available. Now other section is your output sections. So we are having a total 8 ports are given. In some cases it depends on your functions, how many output ports you need to be utilized. If only one function is there, then only one output port will be utilized. If it is 4 K map you are designing, so in that case you require the 4 for different equations, logical minimize equations, you require the different output sections. Now here first one is your input section, second one is your sockets where we are actually mounting the ICs, and third one is your output sections. Now but for running any IC we require the some VCC and the ground section. So we are having a VCC for that particular whatever the IC we are using throughout the practical sessions, that ICs require the VCC power that is equal to 5 plus 5 volts. So here the plus 5 volts are there. Then ground section is there. So different ports are given for the ground sections and the VCC port. So you can use any port for the ground and the VCC port. So here 2 ports are for the VCC and other ports are given for the ground purpose. G and it indicates ground. Now in some example like a B group where we need a flip-flop kind of IC, so for that purpose we require the clock pulses. So this section is utilized for the clock pulses. So to assign this section, so this section is considered for the clock pulses, and this section here 7 segment display. So in some experiments we are using the 7 segment display, like your counter experiment, BCD adder experiments, and the clock pulses is going to be used in a second group or for the sequential IC. Now regarding IC, so how we can mount the IC. So for any IC, if you are considering a basic IC, now we require this IC. So whatever the basic IC if you consider, so for basic IC there are only total 14 pins are available on the IC, and here if you consider here 40 pin socket is there, here zip socket is there, here 20 pin number zip socket is there, here 40 pin number zip socket is there. So you can use any socket for mounting this IC, but before mounting this IC you need to identify the IC. So each gates are identified with the help of number, each IC having a one number. With the help of that number where we can identify the which logic gate is actually implemented on that particular IC. So here if you consider this IC, so in this IC first you need to identify all the pins. You have to check all the pins if it is properly connected properly or not. So if any one pin is break here, so you have to you don't consider this IC for your experiment. Don't use this IC if the any pin is break from that IC. So here a number is assigned. If you observe, so the number is assigned on each IC. So here if you see here some number is there. So second line if you able to read, then on second line there is a number indicates 7408. Now you can easily say that if it is 7408, then AND gate is implemented on that particular IC. If it is 7432, then we can say that there is a OR gate implemented on that particular IC. Now on each IC there is a one U notation is given. From that U notations you can observe that here you can easily see here 08. Here you can note 74 LS08. Whatever the IC we are using in this practical sessions, all ICs are TTL based ICs. Okay, so this is 7408. We can easily say that this is a OR gate. Now here U shape is there, so it is easy for calculating the pin numbers, because left side pin is considered as a 1 and right side pin is considered as a last pin for any IC. So 1 7, then 8 to 14. In this way you need to calculate the IC pin. Now another thing is related to your IC. While mounting this IC on any zip sockets, you have to properly mount the IC. Now here I have mount the IC on this socket, but what happen exactly while mounting the IC, always you have to keep your U shape or consider the first pin here in this socket. But if you observe, this is a 20 pin socket is there, and where IC is only a 40 pins. So how we can manage these pins? So if you put this IC in a very first slot, then the pin configurations will be start from this one, P1, P2, P3, in this way up to 7. Then your 8 number pin is present at the right side, so you should calculate your 8 number pin, or you can start your 8 number pin from this slot, that is P14 is now my 8 number. So 8, 9, 10, 11, 12, 13, 14 and 15, sorry 14. We are having only a 14 pins. So 8, 9, 10, 11, 12, 13 and 14 numbers. So in this way you have to calculate your pins, because it is very essential part, you should understand. The next thing is, if you are not properly mount this IC in a first slot, suppose I have mounted this IC from bottom side. Okay, so it means that this pin is my 7 number pin and this pin number is 8. So first we need to calculate. So this is my first number pin. Now second, third, fourth, fifth, sixth and 7. In this way, now if it is 1, then it should be a 14. So 14, 13, 12, 11, 10, 9 and 8. So in this way you need to calculate your pins, because if you see the IC diagram for any logic gate or basic logic gates, it looks like, see here, if you consider the 7408 IC, so it is the AND gate IC. If you consider 7432, then it is considered as a OR gate IC. Now if you check here, so here in this case 1 to 7, then 8 to 14 pins. And how many gates are implemented on a single IC? There are total 4 gates on a single IC. For any basic gates, if you consider your OR gates, OR gate, XOR gates, XOR gate is a derived gate, but the pin configuration for these 3 gates, OR gate, AND gate and XOR gate, is same. So, and number of gates which are implemented on each IC is also same, because 4 for AND gate, 4 gate OR gate is implemented on 7432, and 4 XOR gate are implemented on the 7486 IC. So these are the pin configuration. From that one, you need to identify which pins are considered as an input and which pin is considered as an output. So keep in your mind, for this IC 7408, 1 and 2 is an input and third pin number is considered as output, 4 and 5 is the input and 6 number pin is considered as a output. Now in case 8 number pin is considered as a output, 9 and 10 is are inputs, 11 pin is considered as output, 12 and 13 pin number is considered as a input pins, 14 is always VCC for any basic gate, and 7 is a ground for any basic gate. So keep these pin configurations in your mind, because we are solving a basic example. For that purpose you require this pin configuration. Now you should always, I recommended you always mount this IC in a very first slot. Now we'll see the basic example. Through that example we'll solve the basic example, implement this basic example with the help of this trainer kit. Now consider this is our basic example. Now in that example a truth table is given. Now if you are considering any combinational circuit, now this is a simple example of any combinational circuit. So very first thing is to implement a combinational circuit. What you have to require, first you have to design the truth table. For that purpose you require the problem statement. So suppose my problem statement is binary to gray code converter. So that is a problem statement and you need to design this code converter. So for that purpose you need to first design the truth table. From that truth table, design the K map. From K map, calculate the reduced equation and draw the circuit diagram. And that particular circuit diagrams we need to be implement on this digital trainer kit. So here I am considering a simple example. In this example, already truth table is given, where 3 min term 3, 6 and 7 having a high values, and other values or other min terms having a value 0. So that is our basic truth table. Now from that truth table we need to design a K map. So how many inputs variables are there? 3 variables. And how many outputs variables? So output variable is only 1. In some cases, if you may be find out there could be a number of outputs variables. So for every output variable you require the 1 K map. Now here in our case only 1 output variable, so we require only 1 variable, output variable, or 1 K map. Now if you consider 3 variable K map, I have designed 3 variable K map. In that K map, just design the K map, assign the variable value in the form of gray code, then assign the sales number. Now 3, 6 and 7, only having a high values. By default form we are considering is a SOP form. So 3, 6, 7, if I am considering these three values. Now next thing is group. After making a group, here I have find out only two groups, so my final terms will be considered as a only two terms. Final equation there could be only two terms, so this is a first term and this is a second term, and plus sign because it is a required in a SOP form. So this is a minimize equations from your K map. Now we want to design the, or we want to draw the circuit diagram. So for this equation, this is your circuit diagram. So A into B AND gate. Now here AND gate. So for AND gate, which IC is considered, that is 7408. Now second AND equation is B into C. So this is a B into C, and again AND gate is there, so we require the 7408 IC. Now for both term we require the OR gate. So OR gate, and your final equation is this, calculate function is calculated. Now for this gate you require the 7432 IC because OR gate is implemented on 7432 IC. Now first thing, observe the circuit diagram. In circuit diagram, how many gates are there, what are the different gates are present in circuit diagram, you need to be observe it and then calculate the number of gates. Now for this particular example, only AND gate and OR gate. Now calculate the number of AND gates and number of OR gate. It may be happen that in for other examples you having here NOT gate, so you have to consider third IC for the NOT gate, that is nothing but your 7404. Now here how many ICs, after calculating the number of gates, first identify which type of gate, here AND gate. How many number of AND gates, here 2 AND gates. So how many ICs we require? Now the question is, for this circuit diagram, how many AND gate IC we require. For that purpose you need to calculate the number of AND gates. Here only 2 AND gates, and we already seen that on a single AND gate IC how many gates are present. If you check this IC pin configuration, if you check, so total number of gates are 4, but for this particular example we require only 2 AND gate. So how many IC we required here? We required only 1 IC. Now similarly for OR gate, how many OR gate? Number of OR gates are 1. So how many ICs we require? 32 IC, 7432 IC. So it is only one gate, so we require only one IC. If it may be happen that in your circuit diagram there could be a 5 AND gate and 2 OR gate. So for implementing the 5 AND gate we require 2 IC 7408, because on a single IC we can implement only 4 gates or only 4 connections. So for fifth one we require the another IC. So from that IC 3 are unused, only one gate will be used, that is okay, but you require the 2 ICs for 5 AND gate implementations. Now here we'll start our implementations part. Keep in our mind our equation is A into B plus B into C. So first AND gate A into B, second AND gate B into C, and both we are connecting with a OR gate. One thing is that before implementing the circuit diagram on a digital trainer kit, you need to assign the numbers to logic gates in a circuit diagram, so it is easy for you to implement for the implementation purpose. Now here for this example I am considering first AND gate. So for first AND gate I am using the input 1, 2 and 3 is the output, that is the first logic gate. Second AND gate, so I am considering fifth and 5, 4 and 5 is the input pin and 6 is your output pin. So for this gate only one gate, so 1 and 2 input pin and 3 is your output pin. Now what happen while implementing, consider 3 number pin will be given as a input to the first OR pin. 6 number pin of AND gate will be given as a second input of the OR gate, and then finally you are getting a output at pin number 3. It means that A, B, C is nothing but your input part, and at from pin number 3 you are getting the actual output. What we require in output actually, when you are giving a combinations like 0 0 0, so your output should be a 0. When you are giving a combination 0 1 1, then your output should be a high. So for 3, 6 and 7, when you are giving a combinations of 3, 6 and 7 in the form of binary, then for these 3 inputs your output should be a high, and for remaining case your output should be a 0. So we'll start the actual implementation part. First thing, you have to properly mount this IC. I am using a first slot. Again observe the pin numbers here, 0 8, so this is my AND gate. Now I am considering this is my OR gate 32 IC, and this is my OR gate IC. See, before mounting this IC you need to check whether pin is break or not. Here these pins are break, so I have to consider the another IC. You have to properly mount. This is a lock. If it is vertical, then it is unlocked. After mounting the IC you have to make a lock. Then another thing about the patch cord or the cables or the wires. So we are having such kind of cables. So before using this cable you need to check that cable is properly working or not. So simple method is just on the switch and check this cable is working or not. If it is LED is blinking, then we can say that this cable is properly working. So in this way you have to check all the cables before using the patch cords or the wires in while implementation purpose. Now very first thing is what you have to connect the ground and VCC cable. Now I have used the first slot, so it is indicate that, see, if you are using a first slot, so it is easy for you calculation purpose, at least for the left side, because it is directly marked 1 2 3. So here 7 number pin, so I have to connect to the ground. Then second IC is this one, again 7 number pin, which is used for the ground purpose. Now VCC or +5, so it is on pin number 14. So after 7, this is my 8 number pin, and this last number pin is nothing but VCC. Now here while you are mounting this one, if you are having a less number of these ports, so what you can consider, so I am connecting again 14 number pin of a second IC. So you can, in this way you can use a multi connection, no problem. So in this way you can use the multi connections, no problem. But if you're having a sufficient port, so instead of doing this you can use a separate port for the connections purpose. Now I have connected ground of both IC, and then secondly I have connect VCC of both IC. Now I have to consider the AND gate first, because there are two gates for we need to utilize from this IC. So I am considering these switches as a input part, so ABC. Now first thing is ABC. C is a least significant bit and A is a MSB bit. So I am considering, you can use any pins, no problem, randomly you can consider, but for reminding purpose, I am using a as a MSB, then second will be a B, and third will be a C. So I am considering this is my A input pin. I am connecting it to the first pin, because first and second is my A and B. We are getting this equation at pin number 3. 4 and 5 we are getting, that is B into C. So I am just implementing the first AND gate. So A and B. So A second pin you have to consider the B input. So this is my B input. I am connecting. Now third number pin, this is your output. Third is pin number says output number pin. So it should be connected as per the diagram or as per our numbering. Third pin should be connected to the first pin of your OR gate. So here I am connecting third number pin. This is my third number pin. I am connecting to the first pin of OR gate. This is P1. Now second AND gate. In second AND gate, 4 is a B, 5 is a C, and 6 number output pin should be connected to the second pin of OR gate. So fourth number pin of AND gate should be a B. We already considered the B, so you can use a multiple connections, no problem. Then fifth number is your C, so I am considering C here at fifth number pin. Now sixth number pin, this sixth number pin, if you observe, so this sixth number pin is your output, and we are connecting this output pin at pin number 2, and so AND gate connections are over, because we required only 2 AND gates, so we already implemented these 2 OR gates, AND gates. Now the second part is OR gate. So first and second pin is already connected. Now remaining piece is your third 3 number pin, and it should be connected to the output section. So this is a third number pin, and I am going to connect it output section. So here your connections are over. Now we want to check the output part. So for checking the output part, you require the truth table. According to our truth table, when your ABC inputs are 3, 6, 7, then your output should be high. For other combinations, your output should be a 0. Now we'll check it. Now you have to assign the input combinations, and for input combinations you need to check the output part. So here I am assigning the first is 0 0 0. All 3 bits are 0 0 0. So your expected output is 0, that is LED should not be blink. Now I am assigning the input at 0 0 1. Now this LED is blink now. So because this is a B C value. Now C is a 1, so output should be if you calculate decimal value, then it should be a 1, and the output is 0. Now I am assigning 2 0 1 0, so output is low. Now I am considering 3 0 1 1. Both LEDs should be blink. Now for both LEDs, so your expected output, so LED should be blink. Now here, see here, suppose I am assigning the 3, then LED is blinking now. Now in this way you have to perform each and every combinations, input combinations, and check whether as per your truth table, if you are assigning the 0 1 1 1, so you are getting the output is high. So you have to try each and every combinations and check whether the output is coming properly or not. If your connections is okay, then it is surely that you will get a right output. Now I am considering 6, so 1 1 0. For 1 1 0, if you consider this LED, So this LED, both LEDs are being okay, and third one is 0. So 110 is nothing but 6. For 6 also you are getting the proper output. Now 7. So all LEDs from input side are high. Then for this high, your expected output should be high. Now I am considering 5. 101, so it is low. So in this way you need to be perform the experiments in digital trainer kit. Thank you.